software, especially legacy software systems, grow big and big and big as organizations grow. And suddenly it become impossible, or it become very challenging to evolve such kinds of software, especially the legacy software we have in organizations that deal with health, finance, and the like. Then they become very big, and it become very difficult to evolve them. So that means if you have to change that software, a component of that software, then you have to redeploy the whole software, and it takes a lot of time. And you have to test the whole software if you have to change a single functionality or a single component, because they are built usually based on monolith applications. So you might have heard about the US tax management software, which was crashing during the COVID time, and big airline software and big finance softwares becoming very slow. And that is because, like, whenever there is a change, then it takes a lot of time to test it and to deploy it and to make sure it runs smoothly. And the other thing that people look at is the emergence of software as a service. In the past 10 years, we have seen lots of changes in the software domain. So cloud computing, one of them, and microservices, another, which sells itself as software as a service or function as a service, or computing power as a service. Instead of you implementing everything, then you buy these things as a service. So there is a significant move in that direction. And the other aspect is, yeah, cloud computing become very powerful, edge computing become very powerful, and it is very appealing for so many organizations in terms of cost, in terms of managing the system, the security, and a lot more other things. So it becomes very appealing, and organizations and software developers want to move their existing systems to the cloud. But if you look at the economic aspect of that one, which is related to cost saving, then running the whole software as a single component on a cloud computing or an edge computing is not feasible in terms of cost, in terms of time, and in terms of resource, because there will be lots of components in it, subcomponents in it, that will not be used. So people want to implement that in an efficient manner, in an efficient way, which will reduce the cost and improve the speed of their software. So all these things together and other factors push software companies to look into different options for improving their existing monolith systems. So one of them is software as a service, which appeared before microservices. And now, since 2014, 2015, we have lots of work done around microservices. And I will talk about these two things briefly. So when I say monolith architecture, it is a kind of application or any software system which is based on monolith architecture. So that monolith architecture tries to combine the different components of a software as one big software, and then it runs as a single component. It runs as a single component. So for example, if you take a financial management system, even if the financial management system has lots of smaller components, it runs as one single component. So the software, you deploy the software as one single component, and whenever there is a change, then you implement that as one single component, and there is no separation of the components. There is no independent running of those components. And such kinds of software are called monolith applications. then they usually run as a single system, And so when there is a change in one component, then it requires a change in all the components, or at least you have to test that change, whether it works well with the whole component. So that's what we mean by a monolithic architecture. And when it comes to microservices architecture, it is an alternative to monolith applications. And what it does is it tries to decompose, or it tries to run the different components separately. So each component will have a single responsibility, and each component will have its own database that it is associated with, and its logic is exposed via APIs. So the big monolith architecture is divided into smaller independent components that can run by themselves, but they communicate each other using APIs. And the advantage of this is, like, the different components will have singular responsibility, and there will be a high cohesion and low coupling between them. And it is also useful for maintaining low perturbation. So when we say low perturbation, we mean that, like, whenever you want to change something, then you don't have to change everything. So it allows you to change only few components of the system, so that doesn't disturb the rest of the system. So it allows us to achieve that. So that is the rationale behind moving monolith applications into microservice application. So people have used microservice application in the past, and in nowadays as well, in two ways. The first one is to abandon the monolith application and build a microservice from scratch, which is called a kind of greenfield approach. And the other option is, like, it became very difficult to do that because of the size of the monolith application. So they look into decomposing the monolith into a microservice. So decomposition of monolith into microservice become a very big research by its own, because there is a lot of interest around that area from industry, and people are very much interested to come up with different methodologies to do it. So is that okay so far with the speed and the description, everything?
So far, no problems.
Okay, great, perfect. So let's continue. And then we decided to do a systematic literature review in this area. You might ask why. First, I was involved in a project called Future Software Systems Architecture, which is funded by Department of Jobs and Enterprise in Ireland. And so the whole idea of that funding is to come up with new methodologies in the area of software engineering. And so when we started that project, then we immediately found out that there are lots and lots of unanswered questions. And so we couldn't find a very good literature summarizing the advancements and the areas. And so there are lots of many open questions, and the future research is not yet, that didn't have a very good framework at the time we started this literature review. So what we did is, in order to provide some academic foundations for the people who are involved in this project, because we had lots of programmers and those people who are implementing the project. So we decided to provide them with the rationale behind doing this, and the rationale, the technologies and the tools that are currently that were used actually at that time, because we started it in 2020. So there weren't enough resources to look into and to learn from. So we started it as a weekly review. So I review different literature and present those literature findings to the group. And then we start discussing lots of things. And the more we discuss that, then the more we get convinced that we do a systematic literature review. So this whole literature review emerged from that discussion, basically a discussion similar to what you are doing. So so what we did is we tried to look into the existing literature review. And so the existing literature review mainly focused on migration problems and challenges. Basically, it focuses on the SOA migration. And so most of the literature was around SOA. And the other one is, it talks about microservice extraction, but it only focuses on the minor aspects of microservice extraction. And it also deals with microservice architecture. Architecture was very interesting for many of the academics in this domain. So they talk a lot about the architecture without talking about monolith to microservice decomposition. And there is also a lot of interest in cloud migration. But cloud migration, again, doesn't basically focus on the monolith to microservice decomposition. So our project and our interest was to come up with an efficient approach to transform a given monolith application into a microservice. So that was our aim, and this existing literature couldn't answer our questions. So our interest was to look into decomposition phases. What phases are there when people try to decompose monolith into microservice, and what approaches do they use, what tools do they use, and what methods are available. And we also look at the metrics, the data sets, and the benchmarks. These were our questions. And we were also interested, what are the gaps? Because one of the objectives of that project was to become a kind of spin out. So we were all interested about the gaps and trying to be ahead of everyone, trying to fill those gaps. So that was our interest. And so we planned the literature review. We followed the systematic literature review by Kitchenham. And so it has three phases: the planning phase, the selection phase, and the analysis phase. So in the planning phase, we identified 4 research questions. The first one is the different phases of monolith to microservice decomposition. What are the phases that are used in the literature or that are used by other people? And the second one is, what are existing approaches, tools, and methods observed in the area of decomposition of monolith to microservice? And the third one is, okay, what are the metrics? Are there benchmarks? How do we evaluate it? And how do we compare performance? So that is the third question. And the last one was, what are the gaps? Obviously, there were lots of gaps. Still, there are gaps. And what are those gaps? And then we asked ourselves, can we fill some of these gaps? So that was the objective of the literature review. So it might be interesting for some of you, but it might not be as such interesting for the rest of you who are not interested in literature review. So what we did is a systematic literature review. In nowadays, if you want to do a literature review paper, then the requirement become very much robust. So I recommend you to start as early as possible to follow a specific methodology and to make sure you follow that methodology and you justify your actions. So that's one of the things that we learn. So in the initial search, we identified the search topics, monolith, microservice, and decomposition. Then we also identified search keywords and we combined them in so many different ways. And we identified the search platforms for computer science. We identified 6 of the search platforms. And in fact, Google Scholar is at the end a kind of aggregator which looks into all of the others. So we conducted the search. We found 5,022 results. This is a very big result. We were dealing with this in groups over a long period of time. And majority of them are blog posts. As you know, there are lots of blog posts about new topics instead of, proper literature review. So we move through the data cleaning and the refinement stage. We have a number of refinement stages because one of the reasons is because the topic is new for us as well. And so we applied multiple refinement stages and snowballing. And finally, we identified 33 papers plus additional 2 papers as a result of the snowballing. And we reviewed 35 papers. And when we moved to the analysis phase, so we analyzed these 35 papers. In fact, to be frank with you, we analyzed more than 150 papers, even in order to decide whether they have to be included or not. And each time we present, I present those papers to the group on our weekly meetings. But within these 35 papers, we conducted a systematic analysis. And in that systematic analysis, we applied the idea of ground theory. And ground theory allows you to explore new areas and new topics by following a systematic steps. And so you keep adding new ideas, you keep adding new knowledge, new concept as you keep reviewing the new papers, the additional papers, and until you reach at a stable version of your understanding of the literature. So that is what we used. So we try to extract as much information from the papers as possible to answer our research questions. So this is the literature review. And one of the other lessons that we learned while doing this, and especially during the review process of the TSE paper, is the reviewers are really, really critical of each and everything that we did. And they wanted us to present all the evidence. So I strongly recommend you, if you are thinking of literature review, make sure you collect your evidence. Make sure you put them together in a very systematic way. So one of the challenges that we had was the meeting discussions that we have, we simply keep them as notes, but we could have done that in a very systematic way. Then we have to go back and we have to extract that information from the video recordings. So it is much more better if you understand the requirements and make sure you collect your data. So as a replication package, they keep asking us to provide them the evidence. So all that thing is something that we learned about literature review. And nowadays, doing literature review for high impact journal requires a lot of resources to be presented as a replication package. So that is my advice here. So when we move to the review, these are the findings that we have. So the distribution of the papers, as you can see, the the research papers, particularly conference papers and journal papers, grow year by year. And in 2020, we have 11, but in 2021, halfway, we have 9. And after the literature review, I saw several journal papers appearing every day. So it is a growing area actually, and majority of the papers are like published in conferences and journals. And in terms of the venue, these are some of the conferences that publish this area. So the Asia Pacific Software Engineering Conference, the European Conference on Service-Oriented Cloud Computing, Service-Oriented System Engineering Conference, and IEEE International Conference on Web Services, and the like. So we have majority of the papers published here. And in terms of journals, in fact, the number of journals that are published are small, but many of them like try to include this topic in their recent calls. And so we have Transaction on Software Engineering, Journal of System Architecture, Journal of Systems and Software, Software Practice and Experience, Scalable Computing, Practice and Experience. These are some of the journal papers that are publishing in this area. So for anyone interested, you might need to revisit them. And so as a result of our analysis, specifically from our ground theory, what we found is a framework. So we came up with a framework for classification and comparison of monolith application, and we call that Monolith-to-Microservice Decomposition Framework. So we tried to put that in context. So the first thing that we have here is the different phases. So that relates to the first research question. So we have phase 1, phase 2, phase 3, 4, phase 5, up to phase 6. And we try to classify the phases in this way, because some of them are already used by previous literature, but some of them are new to our contribution. So phase 1 focuses on input collection. Phase 2 focuses on monolith analysis. And phase 3 focuses on, microservice identification itself. And phase 4 focuses on optimizing the identified microservices. And phase 5 focuses on evaluating those final microservices. And phase 6 relates to deployment. Phase 6 is a very thin phase currently, but hopefully it will grow big in the future. So in terms of data collection, majority of the papers that we reviewed use either of these 4 data collection methods. So for those of you who are dealing with model-based architecture, then you will be able to understand this very easily. So model-based input collection. So this model-based input collection focuses on looking at the specification of the software application itself instead of the code or instead of the application. So they go back to the documentation of the software. They look at data flow diagrams. They look at ER diagrams. They look at activity diagrams, and they try to identify the components of the software from the documentation, even without looking at the software itself. The second one is code-based input collection. So this kind of collection, majority of the papers, again, instead of going to the model-based approach, they look at the source code of the monolith application, and they try to identify useful inputs. So they try to simply analyze the source code, either using static or dynamic analysis. And the third category uses a version-based approach. So what they do is they look at the different versions of the monolith software, and they try to extract information about which component is evolve together. So that is another area, but version-based approach was not used separately. Either it is used with model-based or code-based approach. So the other one is log-based approach. So this is more of collecting the log data and looking into the log data and trying to analyze the behavior of the monolith application. And all this data collection is in the hope of finding some components that evolve together or that run together or that work together. So we have these different methods. And in terms of the type of data, the literature, the existing approach collect. So the most common data that they collect is static data. So that is usually the source code. Mostly they look into the source code and they try to identify the different components of the source code. And the second one, which is taking, which is gaining a higher emphasis recently, is dynamic data. So dynamic data is generated by running the source code and capturing the behavior of the monolith application at a runtime. And so nowadays we have lots of applications that allows us to capture the dynamic data while the application is running. But it has its own disadvantages as well. I will talk about this later on. And we also have model-based data. So as I told you, ER diagrams, data flow diagrams, activity diagrams, all sorts of diagrams provide information. And we also have version-based data. So Git is one of the source of information for this area. And in terms of analysis, once they collect their data, either they do static analysis or dynamic analysis or version analysis or domain analysis. This corresponds to the input method actually. So it is more of analyzing the data that they collected. And this is another interesting aspect that we found, unit of analysis. So method-based analysis is gaining significant traction these days, but it takes a lot of time and a lot of resources, because when you look at method-based analysis, that is the smallest we have found so far, the smallest unit of analysis. And what it does is it tries to look into each and every method of the monolith application. And obviously you may end up with hundreds and thousands of methods running in a monolith application. And it is very expensive. And the second one is class-based. Instead of going deep into the methods, they simply focus on the classes and they try to look how the classes interact with each other. And the third one is software component. This is component-based, like package and the like. So they try to look at a very higher level than the class, and they try to see how the components interact, with the hope that each component or related components become microservices. And another one that we have seen is URI-based analysis. So instead of going to the methods or the classes, they focus on the URIs, those classes or those methods exposed to the external world. And there is one research paper focusing on URI analysis. And finally, we have software artifacts. So software artifact widely corresponds to model-based input collection. So they try to analyze that. Usually, experts trying to analyze it manually in order to find how the artifacts interact with each other. And all this data is either converted into graph. So they try to do graph matching, graph searching algorithms, or they represent it as execution traces. And so trying to represent each and every execution with all the information that it has, or it could be represented using word embeddings in some of the papers. So what they do in word embeddings is they extract the keywords and the semantically content-bearing words from the code, and they try to represent it as a vector. And essentially, the next process becomes vector similarity analysis or clustering. So these are the three widely used input data representation, but other papers have used some additional methodologies. So just to summarize everything, here we have data collection methods: model-based, code-based, version-based, and log-based. And this can correspond to any of these. The papers mix and match all these different parts. So it could be static, dynamic, model-based, and version-based data that is collected. And they analyze the static aspect of the code or the dynamic aspect of the code at runtime, or they do domain analysis, or they do version analysis over a long period of time, especially from Git repositories. And yeah, either they analyze the method level or class level or software component level or a specific URI level or software architecture level, software artifact level. And then they represent this as graph or execution traces or word embeddings. So what do they analyze actually after collecting all this information? What do they analyze? So essentially, the problem is reduced to clustering, the problem of clustering. So why to the problem of clustering? First, we don't have sufficient examples to use, for example, to apply for supervised learning. So supervised learning at this stage is not feasible because like majority of the papers do not have good examples of a monolith application turned into a microservice application. So it is unsupervised problem. So for the unsupervised problem, what they try to do is they try to cluster components. It could be the methods, or it could be classes, or it could be the other units of analysis that we have seen. Then what they try to do is they try to cluster those components that run together most of the time. So for example, if 5-6 classes are run together all the time in the dynamic analysis, or if they have a significant call between them when you do the static analysis, then we group them together and we consider them as candidate microservice. So that is the rationale behind doing cluster-based analysis. So they have used hierarchical, several variations of hierarchical clustering, k-means clustering. They use genetic algorithms and some other specific clustering algorithms. So the problem is essentially reduced into a clustering algorithm. So I might be taking too much time. Is that okay, guys? Is the timing okay? Okay, great. So after conducting these clustering algorithms, like significant portion of the literature that we reviewed, they focus on clustering algorithms. Some other papers focus on rule-based approach. So they try to come up with rules, and then they try to categorize the software components based on those rules. And then once these microservices are identified, the candidates are identified, then some papers look into optimizing that microservice candidates. So they use the non-deterministic sorting genetic algorithm 2 and 3, as well as strings Pareto evolutionary algorithm 2. So what they try to do is, once they cluster the components into multiple clusters, then they further try to filter out those components or those clusters that can be used for extracting microservices. So they focus on these areas. And in terms of metrics, in order to determine whether two clusters are similar or not, or whether two unit of analysis, say methods are similar or not, then they used several metrics. So the metrics are used in two ways. First, to cluster, and second, to evaluate at the end. So in terms of clustering, they use coupling metrics, cohesion metrics, non-functional metrics, such as the amount of data that is generated, or the amount of time that it takes to complete a specific task, or the amount of URIs that they call. So this is non-functional metrics. And again, the other important metrics that they use is the cluster size. So like if you have one big monolith application, then the cluster size really matters when you decompose it into smaller software components. So the bigger the cluster, the smaller the microservices. Maybe you might end up with multiple microservices that become very dependent on other microservices. So in that case, you group them together and then you try to combine them. The lesser the number of clusters that you have, the bigger the chance that you end up with a microservice which is similar to the monolith application. So the balancing the cluster size is really a major issue in those papers. And the other thing that we looked into is benchmarks. Are there benchmarks? Can we compare one with the other? Then in that case, we try to see the code bases that are widely used and the methods that they followed. So in terms of programming language, Java is the most widely used programming language in this analysis. But unfortunately, legacy systems not only use Java, but also programs like COBOL, Fortran, and the likes. And those programming languages never get the emphasis they deserve. So majority of them are Java-based. As you know, Java is a recent programming language, and it benefited from modern software engineering. So the problem is not as complex as the programs that we have, or the monoliths that we have in COBOL or in Fortran and something like that. So Java-based PHP, Python, and ASP.NET are the most widely analyzed code bases. When it comes to deployment, there is little emphasis given to deployment. What do we mean by that? So majority of the papers analyze the monolith, identify candidate microservices, evaluate them, and they stop there. So they let the programmers to implement it, and there is no follow-up. And it is very difficult to make sure those candidate microservices are the right ones or not, because there is no follow-up on the deployment phase. There is only one paper that talks about the deployment of the microservices that are extracted from their algorithm. And they presented the non-functional metrics that they collected by implementing those candidate microservices. And as a summary, so we have the different papers in each of these categories that I discussed. So I will not go through these details because this is very specific detail. Anyone interested can come back to me or refer to the paper. But this is what we found in our analysis, and this framework is our major contribution, because in many of the cases the software architects who are working in this area didn't have this broad and complete picture of the decomposition process. And this is the last bit that I'm going to talk about. So the gaps that we identified in the literature. So when it comes to collection and the data collection methods and tools, they are in their early stage and they require a lot of improvement. So for example, if you look at the dynamic data analysis or the tools that are used to collect dynamic data, one of the major problems that they have is coverage issue. So for example, if you have a monolith that has 100 classes, then the test set doesn't cover all those classes. Even if it covers all those classes, then it doesn't cover all the different methods. Or sometimes, even if it covers all the different methods, it doesn't cover the different if-else logic. So when you collect dynamic data, probably you collect 20 to 25% of the test cases covering the monolith application. The rest of the monolith application won't get coverage. So that is a very big problem. And the other one is we have static data, dynamic data, log-based data, version-based data. So each of these papers looked at these things separately. And there are few papers that try to combine two or more of them, but still that smooth combination, efficient combination needs a lot of research. Like for example, how would you combine the version data with the static data and with the dynamic data? So that's another question. And in terms of analysis, yeah, unit of analysis is a big challenge to pick. So after this, well, during this literature review, the other programmers that we have in our project were decomposing a company monolith application, a financial application with global presence and millions of lines of code. And then the unit of analysis was a big challenge. So if they decide to go for the method level analysis, then running a single clustering algorithm would take like weeks on Amazon instances because of the large size of the application. So that is very challenging. And the other soft challenge that we have is the business process awareness. So like when you decompose monolith into microservice, you are not only decomposing the software, the code, but you are also dealing with the business process itself, the business process the company is using. And it has to match with that business process, or otherwise the business process has to evolve. Then that is the challenging bit when it comes to the analysis. And in terms of identification, existing algorithms work well when it comes to unsupervised analysis or clustering algorithms, but we know that supervised approaches also yield some really good results for other domains. Then there is a huge potential, but the challenge is we don't have sufficient data to train systems. So when I say sufficient data, then what we need is a monolith application, which is transformed into microservice application. And then we learn how that transformation is done. So once we learn that, then we might transform that knowledge into other monolith applications as well. And in terms of optimization, yeah, the optimization metrics are a little bit not clear. So there is a significant work in that area. And neural network approach is also something that we identified as area for investigation. And in terms of data set, yes, again, all the different papers use different data sets as well as different metrics to analyze the success of their monolith to microservice decomposition. But comparison of these different methods is difficult because they use different metrics. So it might be a good research area to come up with a unified metrics that will allow us to compare the different approaches that are suggested. And in terms of deployment, including the feedback loop is crucial. So once monolith to microservice decomposition method generates candidate microservices, then they have to be implemented, and we should be able to see how they perform, and we should be able to collect the data and integrate that data back to the feedback loop. And finally, tool support is a huge area of interest in this space. And that is the finding of the literature review. So yeah, we have some discussion points that we identified, and probably we can discuss on this or any other interesting aspect of this research afterwards. And that's all. Thank you very much.
Thank you. Dr. Abgaz, thanks for the presentation. So some of the speakers are sitting a bit far away from this microphone. So if you cannot hear the question well, I can repeat it for you. Just let me know. Any questions for me, Dr. Abgaz? Yeah.
So as I understand, so are people right now starting to build these monolithic services from scratch, or is the way normally to have to build microservices, or is the normal way to have one monolith application and then transform it into microservice? So why don't people just start by creating microservices when they're building like a huge software architecture?
Okay, that's very interesting question. So in nowadays, those software architects who are building new applications, they prefer to build the application as a microservice-based application. So that is a greenfield kind of application. But the main concern of this this area, the monolith to microservice decomposition, is if you look at the software that we are using, the software system that we are using, majority of them was built like in the 80s, 90s, or in the 2000s, before even we have the idea of microservice architecture. So now the question is, say, for example, let's take a financial institution that provide a payroll system, financial management system, and the like, which includes so many different components. Then the question is, how can we convert that software system, which we are using now, into a microservice? So we are dealing with legacy systems that are already running, but which were built based on monolith application architecture. Then how can we convert them into microservices? But if you look at, for example, Netflix abandoned the monolith application and they immediately adopt a microservice-based approach, and their system is purely microservice based, and they don't, this is not their problem. But for example, if you take IBM or Microsoft, they have lots of legacy applications that are still running as a monolith application. They are trying to, convert them step by step, but they are still running in a monolith application. So this is a problem for them. So the question will be, should we abandon the whole legacy system and build a new microservice-based system, or should we convert that into a microservice-based system? So the question will be an economic kind of question.
Okay. All right. Thank you.
Great. Thanks.
I can ask the next one, perhaps. I hope you can hear me, Dr. Abgaz.
Yeah.
In all those decomposition, monolithic to microservice decomposition papers, works that you analyzed, are they taking as input just to monolithic code base, or is there additional information provided in some of those, at least, like the meta description of this monolithic service, maybe in a unified format, like BPMN notation of what the system is doing? So I think providing these additional kind of information about what the monolithic architecture is doing could be valuable. I wonder if this is also something taken as input into these decomposition systems, or is it just the code base that they take into account?
Okay, this is really another interesting question. Yeah, so the papers that we reviewed, particularly the ones that use model-based approach. So the ones that use model-based approach usually go beyond the source code. And they try to look into the business rule, basically, which was captured during the system analysis and the design phase. And they try to go back and see data flow diagrams, the actual diagrams that were used to build the system. And they also try to include some latent knowledge from the people who are running the legacy system. So they go beyond, and so the model-based approach usually looks into the model that was used to build the system. So they go back to the source code, they go back to the documentation, they go back to the people. So they try to combine that information together. But recently, there is a significant shift from that to code-based analysis. So using static and dynamic analysis, particularly recently, we have lots of powerful dynamic analysis tools for Java, and people are becoming more reliant on that, because one of the reasons that they cite is if they go for the model-based approach, and if they consult additional resources, then it takes a lot of time. So what they do rather is they plug in the source code, and they try to run all the test cases, and they try to analyze the behavior of the system and identify some microservices, and then bring it back to the people, the programmers who are working on that area, and ask their opinion, ask their feedback and the like. So one of the reasons is, I think, the time constraint. So the papers that were published between 2016 to 2018, majority of them focus on model-based approach, and they try to come up with additional external data than the source code. But from 2018 onwards, they become more reliant on the source code and basically the static analysis and the dynamic analysis, because a couple of papers demonstrated that it works well, and then everyone wanted to follow that suit. And recently, log-based analysis is joining joining the hype.
Thank you very much. Maybe as a quick follow-up, not directly follow-up to a previous question, but You also mentioned after your literature reviewed maybe after your work on this survey paper, you mentioned also there are other papers coming up, obviously also in the past year or two. And I guess with the large language models and their very good performance on analyzing code, debugging code, generating code, they do an impressive job. So I assume with this code-based approach, especially in the recent literature, perhaps you are more aware, or are there any examples of decomposition and conversion into from monolithic into microservice architecture using LLM large language models?
Okay, yeah. So recently I was also developing a proposal in this specific area of supervised learning, particularly looking at large language models. And there are a couple of papers that talk about large language models. Probably I will share the links to those papers later on after this meeting, but there are a couple of them. They are not directly dealing with monolith to microservice decomposition.
Mm-hmm.
So what they are doing is, as you said, they use large language models to debug software vulnerabilities. So the two papers that I read recently, they focus on software vulnerabilities analysis. So what they do is they have a huge repository of software vulnerabilities reported before. They analyze those using large language models, and then they try to come up with a model that works well to predict vulnerabilities in new software applications. So what they do is they train their model, and then when you have a new software developed, then you can feed to that system, and the large language model based approach will try to identify areas of vulnerabilities in that software application. But I haven't yet seen anyone using that for monolith to microservice decomposition. And another recent paper is comes from IBM. IBM is also trying to look at supervised learning approach, because they have most probably they have all the data that they need to build such systems, because they have transformed some of their legacy systems into microservice applications, and they have also built some tools which are patented by their name. By the way, there are lots of patented applications in this area. We exclude them because we didn't get enough details about those algorithms that they use. So yes, IBM, and the other one is Amazon, is also looking into this area, but I never came across a paper that uses large language models to transform monolith to microservices. They have used it for vulnerability analysis.
Okay, this could be a promising venue, I think, of research. When you see a supervised learning approach, do I understand right that you have a large data set of existing monoliths and the corresponding microservice-based architecture, and use this as a supervised or labeled data set, so to say?
Yes, exactly, yes.
Okay. All right, thank you very much.
Great.
Yeah, I have a couple of small questions. First one, the follow-up on the previous question. The database, do you have the code database, or is it in some manner of, for example, open API description of API calls, or maybe it's a scheme, maybe done with some kind of notation? How do you analyze this usually?
Sorry, I didn't get your question. Would you please We hit that one.
Sorry, my question was, you have this database of the architecture. Is it, how do you store it? You store it, for example, for the purpose of machine learning. Do you store it as a code base of every project, or all the code that's in there, or some kind of schemes, maybe BPMN notation or any other notation for this particular purpose?
Okay, so so far, what we see in terms of repositories is GitHub repositories that has a pointer to the monolith application, and then another related GitHub application which contains the decomposed monolith, the decomposed microservices from that monolith. So currently, it is just the source code that you will find in that sense. So there is a source code for the monolith application, and people decompose that, and then they put the microservice application as well. So there isn't a unified repository, or there isn't a unified method of putting that together, to be frank with you. So it is usually figuring out the mapping between the monolith application and the microservices. And majority of the papers that do the evaluation at the end, they analyze it manually. So what do I mean by that? Say, for example, you have a monolith application which is decomposed into 5 microservices. And then those 5 microservices have the classes within them. So the list of classes. And then another person will perform a similar decomposition process following their own method. And then they come up with, say, for example, 6 microservices. And then the comparison is which one is better, like in terms of the features that you are looking for. And usually that is analyzed by humans, like experts. And that means, as far as I understand, we didn't come across any unified repository which is used to store that. But usually they are available on GitHub.
Yeah, thank you for the explanation. I have a second question. It's regarding the topic of papers. So as I understand, majority of papers are focused on decomposition. And whether or is there any papers who focus on the support and further development of microservices? Because naturally, after you do decomposition and migrate to microservices, the first thing that rises, the question, it would also rise in the process, and you would need new features built. And yeah, that's something yeah, really interesting to have some research on that, if someone did that. Maybe we encountered something on that particular topic.
Yes, there are lots of papers in that area as well. Our one of the criteria for selecting the literature is for us is the paper has to focus on decomposition. So that is why we filter out the rest of them and focus on decomposition, because our interest is more on the decomposition aspect. So we wanted to transform a monolith into a microservice, an existing monolith into a microservice. So that is why we significantly focus on decomposition. And in our criteria, if the paper doesn't talk about decomposition explicitly, so we removed that out. And if you are interested, then I can point you to our replication package, where you will be able to see those papers that are excluded because they don't have decomposition in them. But the papers were selected in the second and third round. There were candidates, but we excluded them because they don't explicitly deal with decomposition. So I can point you to that resource, and then you will be able to find the rest of the papers that are excluded.
Thank you so much. Thank you for explanation.
Great. Thank you.
We have one more
Yes.
question.
Oh,
Okay.
perfect. Thank you so much.
So my question is, how did you use the results of your paper review for your big, more than millions of lines of code monolith?
Pardon me again, please.
So, you said that you have a huge monolith architecture that made you to review those papers about decomposition. And my question is, with which approach did you end up to cut down or to decompose your monolith?
Okay, so let me rephrase your question if I understand it. So we have the different approaches, and then your question is, have you applied this approach to decompose your monolith application? Is that?
Yes.
Okay, great. Yeah. So yeah, so the future software systems architecture deals with monolith-to-microservice decomposition. So this literature is to support that. This literature review was to support that. And the way it supports us, the way it feeds new information is as follows. So every time we do the review, I try to identify the most important topics that will help us decompose our monolith application. Our case study was a big financial institution. One of our collaborators, industry collaborators, they provide us their version of their legacy system, which has millions of codes in it. So one of the things that we learn from this literature review is the use of clustering algorithms and the use of semantic analysis, how can I call it? Semantic resources. So when I say semantic resources, we look into the source code and we try to extract these content-bearing words, the semantics of the words, and we build a small vector. So that made our application to perform significantly better than the other approach, particularly significantly better than the pure code-based approach. So instead of simply reading the code base and trying to cluster the code base based on the presence of code or the call graph, when we extract these terminologies, when we extract these lexical semantics, what happened is we were able to cluster them together. Say, for example, you have user management, and there are few keywords around user management, and then you can use word embedding to cluster them together, and you can easily analyze the similarity between those words. And there are terminologies that deal with, for example, payment system. And then we were able to cluster those words together. Based on those words, we were able to cluster the methods and the classes that are surrounding those words. So that significantly improved the performance. Unfortunately, there are other really useful approaches that we have applied, but because this now this methodology that we proposed is protected by IP, and I have a restriction not to talk about much on this domain because it is already it is patented. Because industry partners were involved, and actually the rationale for the funding is to come up with some business scenario where we can use this for business purposes. And unfortunately, one of the papers, the actual research papers that we wrote together with one of my students, is also embargoed for 5 years, and we can't talk much about that. So unfortunately, that's the situation, but we have used majority of the resources that we get from the literature review.
Okay, thank you.
There would be one additional question. Do we have some clustering of other industry segments where the papers were coming from, and some more detailed geolocations where the papers came from? So some overview for us to know more of the examples or example use cases for the future.
So is that related to the
You already said financial institutions, but not only related to the things you're not able to talk about, but when it comes to the papers, where or from which industry sectors do they come? Is it a car manufacturer? Is it a financial institution? What else? Not only for the 33 papers you identified as your main sources, but also to the 5,022 other possible papers.
Yeah, so majority of the papers, okay, so if we talk about the 5,000 papers, majority of them are blog posts. So they come from industries, and actually this microservice identification idea come from the industry domain. So even if it comes from the industry domain, majority of the publishers, the writers of those papers were software architects, people who are working in microservices area. So that is why we remove many of them, because they are not scientific publications. But when it comes to the scientific publications, some of them came from Germany, actually, the likes of Service Qatar, I believe, and others from China, and there is some interesting papers coming from China. And in terms of industry, there are papers that are published by IBM, and there is a huge interest from Amazon as well. So researchers in IBM are actively working on this area, and some of the papers we cited are from IBM as well. And the other thing that we have looked, but we didn't include it in the literature review, is the patents again. And there are lots of patents granted for IBM working in the area of monolith-to-microservice decomposition. So yeah, IBM is doing a lot in this area, but Amazon is another big competitor in this area when it comes to the papers. But in terms of institutions, yeah, European and Chinese institutions are the ones that are the forerunners in this area, as far as I recall the location of those papers.
Thanks a lot for that input. Yes.
Great, thank you.
Okay.
I guess that's the end of the questions and today's session, probably.
Yes.
Thank you for the presentation, Dr. Abgaz, and thanks for all the attendees via online or here in person. And we are looking forward to have you again in our next meetup, which is in April, right?
Yeah.
Yeah.
Okay, that is great. Thank you so much. So I will look forward for your feedback, or if there is anyone who would like to ask me any additional questions, or if you have any collaborative ideas that you would like to explore, then yeah, I am open, I am available, and you can share my email to the participants, and yeah, we can engage with further discussion on this topic.
Thanks. Thank you very much once again. Thank you.
Bye.
Thank you.